In this episode of Finno-Ugric machining we are having fun with two connecting rods for this Stirshurst engine. Let's see what this is all about. So this is now the chicken sketch for my connecting rod. I will be making two of these today. So it's just this one goes to the crankshaft and this end to the piston. As simple as that. But it's not as simple as that, because now we have two pistons connected in one crankshaft. Whatever the rod is there, the main peak end. So we need to make it a little bit asymmetric, so that one of these accommodates the other side of the thing and the other one the other side. And I have done some mathematics so that the dimensions should be as they are here, and then they can freely move there. So, the material we are going to use for this one is this, it's hot rolled steel. Okay, so I think I can get two of these out of that. And then for the this beak end, so we are going to use this bushing. It's this is actually it's bronze. It's not brass, it's bronze, and it's a really good stuff. And the inside diameter there, it's 8 millimeters, and the outside is 12. I will actually make it smaller outside because I need to drill this hole. If I make this 12 millimeters and then put this there, I'm pretty sure it will be a loose fit. And that's not a very good idea. And this is because the drills tend to make oversize the holes. So I make it 11.5 millimeters, and then I take in a lathe half millimeters out of this. And how do I hold there? Well, that we will see when the time comes. But there is a way to hold this, and very reliably, and I'm pretty sure I can get it exactly on the dimension I need, so that it will be a very tight fit there. I just push it into place and there you are. So let's go to the lathe and make this kind of piece there first. Now this one is the hot rolled steel is now placed in the lathe. I have dialed it in as well as I could. It's not at all round. And then I have started to peel off from the end, so I know how much I need to peel off to get it round. And our diameter here was 20 millimeters, and I doubt we are not going to get there. We are not 19.5 millimeters. It's enough. Actually, this is not a bad thing at all. It only impacts the breadth width of the connecting rod at the beak end. So, I think I just now peel off this and make this nice. And for that, I will use quite a lot of speed. I have set a hard stop, carriage stop here, and I will not be standing here while doing this, because this is spraying so it will be spraying the cuttings all over the place, so I will be making this with the with the dial here in the back. So let's start with this one, the peeling. It will be cutting something like 1 millimeter. Well, there you are. Clean thing. Clean as a whistle. And now we have this stuff here which I want to vacuum away because it contains the surface stuff of this thing. And yes, it's always a good idea when you do the first cut on a hot rolled steel. Go under the crust. As I'm here, I will also clean up the mess from here. Oh yeah, okay. So the next thing is to, well, wait a minute. Well, we need to take this end 30 millimeters down to 10 millimeters. Shouldn't be too bad. So, and this one will generate a lot of cuttings as well. So, let's see now. I will now adjust this this one to the stop here for 13 millimeters from the end. 13 millimeters. Okay, maybe there, somewhere there. 30 millimeters equals to 10 turns. 1, 2, 3, 4, 5, 6, 7, 8 ja 10. That's counting in Finnish. And we have our stop there. And now sanity check. Sometimes you count this wrong. Sometimes. And it is 30 millimeters. And now we need a micrometer here. And I will take 1 millimeter cuts as long as it takes. And let's see, now I need to put this here somewhere. Like that, maybe? No. Like that, maybe? Yes. I'm just putting a magnet here, like that. Is it good? Yeah, it is good. Okay. And now this is tight, everything is tight. The speed is alright, tight and right. And then we just start cutting, I think. So, this was the first millimeter, yes. Seems to be good to go. think I can raise the speed a little bit. Let's see. Yeah, definitely better. And now I'm trying to make a finish here. So I will take only half millimeter, but I will put some speed into it. Let's see. Well, did somebody say that you cannot? Well, you cannot. It's very... the finish is something really unreal. I don't know, it's smooth, but it's not smooth. So let's see how much we need to take as the last pass. And this is still hot, so I will end up having an undersize. Well, it's 10 millimeters and 45 hundredths, 46 hundredths. So I don't take the full half millimeter, I take something like 45. There, let's see how this ends up. One would probably add some lubricant in this moment. That's a definite mistake. If you do that, you will lose your accuracy. The cut will be totally different than the previous cut. So no lubricant, just as you did the last pass. Before the last pass. Same speed, about the same feed and so on. Let's see what it is. Well, it's 3/100 of a millimeter oversize. Okay. Actually, we can peel that off. With this thing, it is really possible. Well, I have a very crappy dial here, so about 3/100 of a millimeter. It's something like that. Let's see. With this insert you can peel off 100ths of a millimeter. Okay, let's take this like that. It should be there. Well, the finish is actually very nice. Well, hot rolled steel, what can you say? Let's see. I would like to show this to you. Sometimes you get lucky. Or was this just sheer luck? It's actually 5/1000 of a millimeter oversize. And with this dial, I think this is well, I think you cannot make it any better. Okay, now we have done the 10 millimeter thing. Let's see what happens next. I will clean this up. A lot of things here, and also on the table and everywhere. This is spraying the chips everywhere when you do these kind of things. But The nice thing with these chips is that you can vacuum these. These are small, they are not like a bird's nest. So yeah, so this insert it's super for doing things like this. It's versatile and it cuts well. The cutting forces are really good. Okay, I will come back when I start the next phase. There is still some things to do at this end. Of course, as I said in the first episode, this is to learn something. Well, I have to learn to read my own markings. 30 millimeters is not enough. We need 9 more, and it's clearly in my drawing. So yeah, let's take 9 more millimeters. Well, there you are. I'm pretty sure that one is no more. Well, it's correct dimension. So, next thing is to put a 45-degree chamfer here so that it meets the corner down there, and here, well, some also. So let's do that. 45 degrees means that we need to turn this a little bit. Like 45 degrees is about there. And then we need to turn this too. I'm just looking here that it's about straight. When I will parting, then I will put it more exactly, but now this is more than enough. And this one we can throw away. And now free this one. We are going to do the chamfer with the cross slide. Okay, this is okay. Then that one needs to be loosened and moved away from here. About there is the stiffest point. Okay. This one is just to ease up my filing. Well, that's enough, I believe. And then we go here. I believe there is a good point to start. we could probably do some beautifying for it before I part it. Not much of this will be visible later on, but some of it is. Oh yeah. Huh, nice. So, we will be parting next step. It's party time. So, this one, and lock it. If you don't lock this, it will be very musical. And then we need to put this as straight as we can. Maybe how do we put it as straight as we can? Ah, I know how. This is always a little bit different depending on what situation you have. Oh yeah. There you are. Please notice I have bolted this lathe down to the table. It doesn't wiggle anymore, and that's actually quite nice. So what we have to do here is now let's have something flat, and then using this surface just oh, we need to connect this one. Okay, now it's the back side. Okay, now we take it a little bit away like this, and then 55 millimeters. 55 divided by 3 equals 18 turns and 1 millimeter. Ah. 1, 2, 3, 4, 6, 7, 10, 11, 12, 13, 14, 15, 16, 17, 18 plus 1 millimeter. There you go. There is the place. We have everything tight, I hope. This one too. I need to check this because this, when not tight, will actually ruin your work quite easily. Then let's wipe the base a little bit because now I'm going to have the tailstock here as a support for my hand. And let's go. The speed is about there. Yeah. I will now do another identical piece with this one, off the camera. And now I have done two identical pieces now, and I turned it around and put it into dialed it in. Now the next step is to get rid of that nibble. That should be easy enough. This is the parting tool, and it's that's the tool for getting rid of these nibbles. Like that. There you go. No more nibble. Then we change the tool and we make a 45-degree chamfer there, so that the center inside there will be 12 millimeters. So now at the moment the diameter, that's not critical, but we are at the moment at 19 millimeters. So let's see now. I put this somewhere near. Like there. And then a little bit more speed. A little bit, really a lot more speed. Like that. And then I try to touch. Not yet. There you are. So now I zero this one, and as we were 19, so it will be 7 millimeters of the diameter. So half millimeter cuts. Now it is 18, 17.5. 13. Well, time to do a sanity check, I believe. It should be 13. About. Yeah, it is. 13 about. 12.5. And the last cut. Like that. There you are. And then a little bit beautifying. Not a lot. Lathe work is done. Now I just make another one and the other one like this, and then we are done here. And next stop will be the milling machine. Okay, now what I'm going to do next these pieces on the milling machine, I will make some flats on them. First of all, we will be making this flat here, and then furthermore we have to mill the sides so that the total width is 16 millimeters, and as we are now in 19, it will be taking 3 millimeters from each side. And then finally this flat here, which should be half the diameter. And it's the working surface in this case, so This one needs to be quite well done. So the cutter I'm going to use in this case will be this one, because this has low cutting forces and it has makes a decent surface finish. Also without coolant. I don't want to use coolant this time. This is a small part and we can use cutting oil. So yeah. So let's go to the mill and see how will I do this. So now here we are doing this job is that's just my estimation. It's best done with this dividing head. So you can turn it like in 90 degrees for the sides, and you can pretty much turn it in all the positions you need. And now we should dial it in. And this will be really fun. Like that. Is it now in the middle? Well, it's really flimsy. Okay, so well, let's see how it behaves. So there we have. Well, so this is really low. Oh man, and this is really low. So loosen it a little bit. Then go to the opposite side and tighten that. And these are crunchy as hell. This is high. That one is low. I think we are there now. Whew. Okay. Done with my flimsy indicator. This is I don't like this indicator at all. Let's put it there on the lathe. And now we need some tools here. Again, check the tapers that there are no big chips like that's it. Tighten it. It's time. Go back a little bit. This one needs a collet. Oh yeah. Oh yeah, it's clean. It's very good practice to always clean these before you store them. So and I know this is a tad flimsy. And not just that, it's really flimsy. And now, there you are. It's there. Sits there and doesn't go nowhere. Now let's put this into a 0 position, which is there. I use direct indexing here now because we can. And now we are at 0 position, and this we can just put somewhere there that it's, and lock it. Come down. Okay. Down. Go there. Oh, it's the slow gear. Oh yeah, okay. Well, how about that? Now you can see something. So, I already, you missed something. I have touched. So, well, it's I believe 1/100th of a millimeter, so I take that one back. And here in the vertical dial Z axis. So now it should be quite decent. Yeah, it's barely touching. Good. And now we will take very light cuts, and I will speed this up. I will put it on high gear. Like that. That's better. And then let's take 2/10 of a millimeter. And this is all manual wheel. Surface, and yeah, the surface finish is really superior. It's really good. Okay, then we need to turn it 90 degrees, break off, and 90 degrees. So that would be our 90 there. And break on. And now go back to 0 here. This should be now on top of the thing. Let's see if it really is. Yes, really it is. So now we need to take 3 millimeters away. So let's start, and we have to take this. I will take this like a 0.3 millimeter cuts. So. You know, we have now, okay, there's a sharp corner. So now I will do the other side, and I will come back when I'm doing that side, which will be half the way through. This starts to look like a workpiece at the moment. It's really looking, looking like a connecting rod. Well, of course I made a major mistake here. Well, I should have taken, it was 19 millimeters, the original diameter, and our goal was to get this like 16 millimeters. So I just thought simply that okay, 3 millimeters away, and I took that 3 millimeters from each side. So now it's 13 millimeters, but I believe we can live with that. So what I'm going to do now is to touch with this the end of this one, because we need to take 25 millimeters from there to here, or halfway through. So and then let's go back to the original 0. Now we can unlock this one. And it was there, that's 0. There you are. That's our 0, I believe. Yeah. So, this is now locked. And now we are going to use auto feed here. So, sorry about the noise. Slowest speed. And of course we can lock that one, and it was 25 millimeters. Yeah. So let's take 0.3. Well, you get the idea. I will do this half the way through, and after that we will use an, well, I come back when I'm finished with halfway through there. Well, here I'm going to drill a 10 millimeter hole into that end, the big end. And well, I have already placed the drill in the correct place, so yeah. And well, this is a little bit flimsy, so we put something not so flimsy under. Like that. Hopefully it goes in correctly. Yeah. I will not tighten this hard. It will just support this in case it will try to flex down. Well, there you are. And I'm going to use auto feed here. Let's see about the speed. Yeah. Well, that's a helicopter. And it's true. Well, 2 chips. Now, let's go. Let's see. Oh, this looks really bad. It's a good idea to do this side as well. Because this side has a lot of wood. Okay, but this end is now ready. This was really loose. Oh man. I will take you some pictures about this at this stage. Well, I debore it a little bit more. Okay, now that I have made 2 of these, quite identical actually, so next step is to machine something on the other end here. But nevertheless, if we have 15 millimeters If we have 0.1 millimeters room there, that's enough. We don't need any more than that. So the thing is that both of the sides should be parallel with that original side. So we have one tool, and it is this slitting saw. This one is really. Where is my tightening tool? This is not the correct one. With slitting saw you can do both sides with the same setup. You are supposed to tighten it, not loosen. And the teeth are on the correct way. Yeah, you don't want to install this wrong way around. If you try to rotate it the wrong way, it will not work at all. So, I think we are there. We need to use, this one works better with low speed. I believe that's okay. So, and I will take this with a single cut. Wow! Oh, have to be careful with this one. Okay. And as you can imagine, the surface finish there is super. Okay, now first side done. Now next thing we want to do is the underside. No chatter, that was a surprise for me. Here I am now drilling a 4mm hole. Actually this is a 3.5 millimeter drill, and I will ream it to 4mm. So I have already placed the table with this pin, and it should be quite there. Well, all is relative. Let's see now. We need a lot of speed actually. We are going to use auto feed here now. Well, yeah. Okay. This one I will feed manually. I want to see what it does. It's the first time I ever use these things, so well, let's see now whether this works or not. seems to work. Yeah, it's producing chips under there. Oh yeah. We are through. Let's put some more there. Yeah. And it's a very fine hole. Okay. Well now, these connecting rods are now, well, not ready, but in a state that they are ready for bushings. And yeah. So when I made the other one, I made a mistake. Again. Well, it's not a big one. Which one is it? Other one is symmetric. This. Okay. The other one is a little bit aside, this one. And that's actually, it might be a bad thing. Let's see. We probably need to trim it by filing at the end. But yeah. Other than that, these look, in my books, well, decent at least. So, now the bushings. It's roughly dialed in. But the main thing here is to make this face this side really carefully. So that's our first task. Okay. So I will do it with this one. Much better. Well, there you are. Now it's cleaned up. Next, let's put this one in there. I think this doesn't need to be really tight. Just, well, okay, that's tight. So now we dial this thing. It looks like it isn't round. Well, let's see. This is 0. This is also 0. This is 100mm over. This is 0. I believe 3 out of 4 is 0, so that's center. 2500ths of a millimeters. Okay. No, actually we have exactly 10.5. Okay, so now, well, we are approaching 10.5 millimeters at the moment. It's absolutely too large, but we need to have it oversized. But how much? 500ths of a millimeter? That's probably too much. So I think the correct value would be something like 3 or 200ths of a millimeter too large. Okay, but now the dial is now matching the diameter. So let's keep everything as is. Another 0.25 millimeters. And I'm trying to make similar cuts so we get similar results. Now, yeah, it's right where it should be. 25, 10.25, and now we should we should leave it just a hair oversized. So this will be, with this dial, this is a little bit should be there. Let's see. Now we should be where we should be. We have 200ths of a millimeter oversize. Oh, can you see it? Hopefully yes. Yeah, 200ths of a millimeter oversize. That should be now totally compatible with that. Let's see, I'm a little bit suspicious about this. Let's take it away. Now it's too late to regret. Oh yeah, mission completed. Hopefully. Well, it's surprisingly centric. So, let's see how it feels. Feels really good. This is a press fit. Yeah. So, I don't have an arbor press. So therefore I need to use my vise for this pressing, and well, I cut this in half, and the thing here is that this surface needs to stay flush. This one can extrude a little bit. I can always file it down because this is just it's a optic surface. So I will push it from this side, and let's start it just a little bit. It's now there. And then I have this piece of tool steel which I put behind here. Okay. Put behind here, like that. And now when I push it, it will actually eventually end up on that surface. Oh, this requires some strength but not a lot. So I think the fit was okay. We are there now. Fit was perfect actually. So there we are. Done. Now I just do the other one and then I file away. have done these two connecting rods. I made a few mistakes with these ones, but hopefully I learned from my mistakes. So, well, pay attention to whether you are... Division by 2 seems to be very hard for me. So, yeah, okay. But, well, let me show you these little things. The bushings were really success. They are sitting there really tight, and not really tight, but tight enough. They don't go away themselves. And then the 4mm holes here at the end. These should also be quite good. Okay, so that was this one. In the next episode of window brick machining we are making the pistons and the cylinders. The cylinders are a little bit different, but the base will be the same on both of them. And this is precision machining with this Chinese lathe, and this will be, it's always fun. Like you saw with these bushings, you can do that. You can machine down to accuracy of 100 of a millimeter with that one too. Well, okay. Well, till the next time, bye!